Hello everyone, welcome back to my YouTube channel. My name is Rishti. I'm in my second semester studying Sri Venkateshwara College of Engineering in the Department of Computer Science. Today I'm going to speak a few words on the topic Taylor series and applications. The contents of this video are: what is Taylor series formula, applications of Taylor series, and we're going to learn about the applications of Taylor series with respect to COVID-19. What is Taylor series? The Taylor series is a mathematical technique which is used to approximate a function by representing it as an infinite sum of terms, each based on the derivatives of the function evaluated at a specific point. This is particularly useful for functions that might be difficult to compute directly or are represented by complex equations. Now let's learn about the representation of Taylor series or Taylor series formula. The Taylor series expansion of function f of x around a point A is given by f of x is equals to f of a plus f dash of a into x minus a plus f double dash a into x minus a whole square divided by 2 factorial plus f triple dash of a into x minus a to the power cube divided by 3 factorial plus and so on. In this function expansion, f of a is the value of the function at the point A. F dash of a is the first derivative of the function evaluated at A. F double dash a is the second derivative and so on. The terms are weighted by the powers of x minus a and divided by the factorials in the denominator. Now let's learn about the applications of Taylor series one by one. Now let us learn about the applications of Taylor series. First one is function approximation. Taylor series can be used to approximate complex functions with simpler polynomial expressions, enabling easier computations and analysis. Second one is numerical analysis. In numerical methods, the Taylor series help develop efficient algorithm for solving differential equation and the mathematical problems. Moving on to the third application, physics and engineering. Yes, Taylor series is used in physics and engineering. It is also used in error analysis and optimization. It is also used in computer graphics and image processing. Taylor series, the third application of Taylor series is physics and engineering. Taylor series are used to linearize non-linear equation, making them more amenable to analysis and computation. The fourth application is error analysis. They help access the accuracy of numerical approximations and methods by comparing them to true values obtained from that Taylor series. The fifth one is optimization. Taylor series approximation are used to optimization problems to find optimal solutions by approximating objective functions and constraints. For example, in the usage of COVID-19, Taylor series is used. So let's learn about how Taylor series is used in processing or in determining the data of COVID-19. Now let us learn the applications of Taylor method on COVID-19. So here in this application, we are going to learn the infected, susceptibility, and recovered individuals of a certain population and about COVID-19, how the COVID-19 spread and how it is infected and how many have recovered. Application of Taylor method on COVID-19. Let us consider a basic susceptible infected recovered model for the spread of COVID-19. In this model, the population is divided into three compartments: susceptible, infected, and recovered individuals. Recovered individuals are the individuals which are recovered from COVID-19. We will use the following assumption. The total population N remains constant. The transmission rate beta represents how easily the virus spreads, and the recovery rate gamma represents how quickly infected individuals recover or die. The first step in the application step is deriving the equation. we want to approximate delta I. I represents infected individuals using a Taylor series expansion around T. T represents time. So here in this derived equation, you can see I, which is stands for infected individuals, delta T stands for time interval, T stands for time. Um, di by dt stands for the first derivative of infected individual. D square I by dt square represents the second derivative of the infected individuals, and so on. Now let's learn the formula. I of t plus delta t is equals to I of t plus di by dt into delta t plus 1 by 2 factorial into delta square I by dt square into delta t square plus so on. Moving on to the second step, that is calculate the derivatives. Calculate the derivatives of infected individuals, that is I, with respect to T based on the SIR modules, that is susceptibility, infected, and recovered model equations. Now let's see the formula or the derivative. Di by dt, that is infected divided by time, is equals to beta. Here beta represents the transmission rate of COVID-19. S represents the susceptibility individual, I represents the infected individual, and N represents the constant population. Here gamma represents the uh, recovered individual, and I again represents the infected individual. Let's learn. Here di by dt is equals to beta s into I divided by n minus gamma into I. And the second derivative is d square I by dt square is equals to d by dt whole beta into si by n minus gamma I whole. The third step includes substituting into the Taylor series expansion, substituting the derivatives into the Taylor series formula. Now let's learn the formula. I of t plus delta t is equals to I of t plus beta into s into I divided by n minus gamma I whole multiplied by delta t plus 1 by 2 factorial into d by dt into beta s into 1 divided by n minus gamma into I whole multiplied by delta t square plus and so on. Interpretation and insights. The Taylor series approximation helps us to understand how the number of infected individuals I into delta t changes over a short time interval. By analyzing the terms in the expansion, we can gain insights into the factors influencing the rate of infection. The terms delta, beta into S into I divided by N minus gamma into I into delta T represents the net change due to new infections and recovering during delta T, that is time interval, and the second derivative term d by dt beta into S into I divided by N minus gamma into I in whole multiplied by delta T square provides information about the acceleration of the infection spread. Now, this is just the theoretical part. This Taylor series expansion can only be used in the theoretical part of suspecting the COVID-19 COVID-19 virus, whereas in real life it is very different. Let's learn about the real life crisis. The real world application is totally different from that of the practical Taylor series applications. In practice, real world COVID-19 modules are more complex and account for factors such as different age groups and demographics, interventions, which include lockdowns, vaccination campaigns, etc. The third one is testing, reporting, and healthcare capacity. And the fourth one is spatial and network effects. Moving on, the real world application, which is continued. Here, sophisticated models often use differential equation numerical method and extensive data analysis to predict the spread of virus, evaluate intervention strategies, and assist policymakers in making informed decisions. Remember that while Taylor series provide valuable insight, the actual analysis require careful parameter estimation, data validation, and data validation against real world observation. So remember, the COVID-19 application with respect to Taylor series is always theoretical, whereas the real world application is entirely different as compared to it. We have now come to the end of our video. Please do like, subscribe, and share. I hope this video was helpful to you. Thank you for watching.